Greetings, hello everyone, welcome to Dev Chatter. My name is Brendan, and today on Dev Chatter, we are going to be looking at some C# performance stuff. This should be fun. So, I have a very complicated program that we've got up on the screen right now. I know it might be difficult to understand. Actually, if you don't know C# very well, it might be difficult to understand, especially for new programmers. But this is what we call the Hello World program. If you are one of those new programmers out there, and Hello World is like the so it's almost like when you first learn a programming language, it's the thing that you run to make sure that you can make code work in that language. So that's kind of sort of what this is. It's not really a how to phrase this? It's not a program that's designed to do anything. It's just literally just here to say hi. Hang on, let me tweak a couple of things. So I don't usually stream on YouTube, as I'm sure some of you know. I usually stream on, well, what's the other thing? Twitch. That's where I usually stream. So I am normally a Twitch streamer, but I wanted to try doing some YouTube streams. I tried one in the past, but we had some networking issues, and I wasn't sure if that was me or YouTube. And so we canned the stream, switch over to Twitch, and it turns out it was on my end, not theirs. But we're back again. I want to try this, see how it goes. So I'm glad to see some people in chat. I want to make sure we say hi before we jump in. As I said, today we're going to be looking at some performance. We're probably going to run benchmark.net and some stuff just with Stopwatch, depending on how much we really want to see, like, is this fast, is this slow? I started this off with the .NET 7 app, and I'm planning on making maybe a .NET, if I have the SDK, a .NET 5 app and a .NET Framework app, and kind of comparing that, because people have been talking about performance improvements in .NET 7, and I want to see what we end up getting from that. So, yeah. Greetings. Hey, SNB, and SNB, you mentioned something, you like, in a message earlier in the chat, you said something like, telling me who you were. Don't worry, I recognized you from the picture next to your name. But welcome, SNB. And yes, I have some nice familiar tunes on the intro. I hope everybody likes my XP loading screen intro that we do, as XP style, I should say, because it says Dev Chatter instead of Windows, but that is a fun one that I enjoy. And there should be commands in the... So I'm just running the Stream Elements bot right now. I don't know which things I've got enabled on there. I don't have my bots running in YouTube yet. Though that, if we do start streaming on YouTube more, will be something we will look at, is how to get our bots chat over into YouTube. So I think that's a good thing anyway, because I would like for some of our tools to be able to work both in Twitch and in YouTube, and I know how to make them work in Twitch already. We've built plenty of that, and it should be possible to make it so that someone can run the application and switch which one it's talking to. So that could be a fun thing to do as well. And welcome, greetings, Bread, Grumpy Game Dev, hello, hello. Hey, Sean, welcome. The Neo, wow, the one has joined us. Hello, greetings. Yes, very friendly. Okay, so we started off with Hello World. All right, how long does Hello World start? How long does it take to run that? So let's do a stopwatch. So I'm not going to run benchmark.net just yet. We're just going to use this for now to get started, because I want to start writing some code. So let's start here. So if you are someone that's ever wondering how slow is any given piece of code, first thing you need to do is learn this one. And the reason why is that you can check date time. So, like, the naive approach to checking the performance of something is to grab, date time dot now, and then, like, this is the start time. You say var start equals this, and then you say var end equals date time dot now when it's over. And then you go, all right, cool, now I got, and then you go, yeah, I've got this. Now all I need to do is say, do my code and then say end minus start, right? And then you get your result, and that gives you the time span. And then you'd have it, and yeah, that's the naive approach, right? And you would say, like, do code here, right? And these don't work very well. And the reason why is this is not a very precise clock. And I guess if you're doing like millions of operations of the same thing, this can probably get you close enough to give you a rough idea of which one's faster. But the stopwatch, read the description. So first off, this comes out of the System Diagnostics library, so it is a diagnostic tool, not a tool for determining what day of the week and what time it is. This is for actually looking at what's going on in code. So that's what this one is built for. And you'll notice it's kind of, the text is kind of small there, so I'll read it. It says, provides a set of methods and properties that you can use to accurately measure elapsed time. So that key being there, accurately, which you will not get from system date time now. So let's not do those for now. So when you make a stopwatch, most people make a stopwatch and they create something kind of like this. And when you create a stopwatch, you're then going to go ahead and you're going to say like stopwatch start, and you're going to do something like for I equals 1 to let's go up to 1,000,000. So if we go from 0 to 1,000,000, we're gonna run this 1,000,000 times, and we're gonna console write line hello world, and then we're gonna say stop the stopwatch and say console write line, and what are we gonna write out? We're gonna say the elapsed time as a well, we could two-string it. Yeah, let's try this. Let's see what this does. So again, I started this hello world, and I'll admit I didn't even run it yet. So we're going to find out whether or not this code runs. And you know what? I can do it over here too. So it doesn't really matter which one we're doing it in. Perf, cd into perf, and then say cd into console, and say .NET run. So when we run this, we should get, a whole bunch of hello worlds. It's going to take a ton of time. It's going to be... oh, is that the one I want? Capital O, thank you. Either way, so this is going to take forever. This is going to be slow. It's going to be awful. It's going to be terrible. We're just going to sit here for a while. And why are we sitting here for a while? Because console output is slow. It is really, really slow. So if you haven't worked with this, just keep it in mind. The reason I bring this up is that some people in current versions of development will do things like running a web server with their console, for example. And if you are spitting out console output for all the requests and other things that are going on inside of your web application, again, that's not really taking much time on a given request, but keep in mind the amount of work it takes. We're just printing 1,000,000 times, right? It's not done. Look how long I've been talking, and it is not done. Like, think about all the other things that we could have done in C# 1,000,000 times, and it would have been done in seconds, and this is not done, and it's still not. So this is crazy. Hey, leading lady, welcome. So it's just ridiculous that, that we're just waiting. I'm not sure if I want to stop this or not, because to be honest, this one's so slow we didn't need the stopwatch. We could have done the date time now comparison between the two times. This is terrible. Yeah. This is good. Yeah. Oh, okay. You use that one. Yeah. I'll tell you, time formats are always fun. I'm one of the weird people. I like to argue about time. So I write dates like a programmer, because we're all a little we're all a little weird, all the programmers. So I like writing year, month, day, even on stuff that like I write. And I like it because I'm like, well, it's super clear, and like year is very specific, and it's like that's the most important thing, and then it's like the next most important thing is which month, and then the date, and so like, and then after the date it is the hour, and then the minute, and then the second. It's like, yeah, so that's the way I write it. I had someone that was arguing. They were like, yeah, Americans use bedtime. I'm like, hey, I'm an American, but I'm a weird one. I use different time. I was like, yeah, I do year, month, day. So this is still not done. Yeah, a little weird. Oh, I'm getting called out. Yes, just a little weird. Just a little weird. You write dates like that, but because you're once... Yeah, so military does the same thing, because it's very specific, it's very accurate, it's very meaningful, and a lot of times it's like, yeah, why not have a very clear order? So I had someone that does... Oh, it's done. Excellent. So I had someone that does day, month, year try to argue with me. They're like, well, I always do it from the smallest to the largest. And I'm like, oh yeah, you write day, month, year, and then you do hour, minute, second. So you go smallest to largest and then largest to smallest. Yes. Tell me about how you're consistent now. You didn't start with the seconds, did you? You didn't go seconds, minutes, hours, days, months, years. It's like, no. One way is not better than the other. However people write it, as long as it's consistent, it's fine. Like, as long as people understand, it's communication. Communication's the key here. Like, yes, there are some ways that are better, worse in some aspects, but it's like, look, everybody's different. As long as you can tell what someone's talking about, you know, whether it's with a label or whatnot, good, it's fine. Communication, that's what it's all about. All right, so we look at this. It took like almost 3 minutes just to say hello. I'll try to keep most of these. I wanted to do the first one like this and let you actually see one of these takes really long, so we can see the result and see that there is an amount of time printed out. So cool. Let's have a look, because we ran that and we started off with just doing like 1,000,000 times and just saying hello, right? But if we did something else and didn't say hello every time, let's say we just added some numbers together. How about we make a long and we just say, you know, j equals, you know, 0, right? And I want to use a different one just so that we're not just incrementing the number, so there is something else happening here. But I could do, you know, j plus plus, right? And I could just do this right here inside of the loop. And again, it should increment that number up to 1,000,000, and we shouldn't have a problem. And this one should be lightning fast. So I have saved that file. Now when I run it, it should compile it, and it should run this. Instead of saying hello world, it's just going to almost immediately spit out the time. So you'll see that the 3 minutes was not going through the loop. It was printing out the hello world message to the screen, which is just silly. ISO format or bust. Hey, all right. If chat's on board with it, we'll ISO format this, right? That's okay. We can do that. There you go. Fixed. Everybody's happy. Oh, and it blows up. See, it doesn't even like it. Okay, capital O. Maybe I had to tell it a format, which means maybe I have to comma and circle the thing, but comma and O the thing. But either way. The point being that when we run this, you'll see that it's taking a tiny fraction of a second in order to run through that whole thing and increment numbers. So incrementing numbers in C# is ridiculously fast. If we want to look at some of the other stuff that might take some time, we could make a ginormous string, for example. Let's make a string, and we'll call it, you know, big text, right? Big text. It would help if I, you know, formatted my code correctly. But, you know, formatting code correctly and following syntax is for suckers. I don't do that here. We just write stuff and make the compiler do what we say. I think. Probably. Okay, so let's engage garbage collection and do this. Yes, we're going to string builder some string builder. So we're doing some of the basics first. We're just going to talk about this and just go through some of these things. And we're starting with stopwatch. I'm not going to bother with benchmark just yet, because we can look at this stuff here and it's fine. So string builder, build me a string. Okay, so if we do this and we just say plus equals I, so I don't even have to convert that. It will implicitly just say, like, wait a minute, that integer for I needs to be turned into a string, and it's going to tack this string on here. Now, this string is going to get absolutely ridiculous if I do it out to 1,000,000. So let's try going a little bit shorter, and even this should be kind of slow. I'm betting we can get a significant thing just out of 1,000, but maybe let's do 10,000 just in case. So we'll do 10,000 times through here, adding into this string. It's going to be a huge string. And then, do we want to print it out? No, we won't print it out. So let's go ahead and run this. And how long does it take? All right, we got not even a half a second. So that's not bad. That's not bad. Let's go up bigger then. Okay, let's try that 1,000,000. And this better get me some garbage collection and problems. Excellent. It's taking a while. This is what I wanted. Maybe this is too long. Maybe I should watch the performance on my CPU right now. I guess I could debug in Visual Studio. It would tell me that. Guess I could debug here and it would tell me that. The you'll notice it suddenly starts crumbling once we went a little bit bigger. All right, let's kill that. Let's try it again a little smaller. What did I do? 1,000 originally, so we'll do 10,000. So it should take 10. It should take more than. Ooh, did I start with 10,000? Maybe I did. Because that's the same time as the first one. But this should take a good deal longer. Maybe like 5-10 seconds. So all of us know use strings and don't do string concatenation because this gets nasty. There we go. So 10 seconds. So that's more than 10 times as long. So that's the key I wanted to get was when you do 10 times as many numbers, it's going to take more than 10 times as long. Now here, it's also because of the fact that we're changing the string to that size. But there are other things that we could do that would make it not so bad. We could, say, be concatenating a string into here to store it and basically essentially create new strings all the time that are getting assigned here. But there are numbers other than powers of 10. That's true, I guess. But why would we do anything other than powers of 10? That being said, I am a fan of using different bases. I kind of wish that that humans had decided instead of using base 10, we were going to use like base 12 or 16 or 20 or 60. One of those. I like those bases just because they have better divisors than 10. So, like, 2 and 5 are great and all, but wouldn't you love to have like the 3 or the 4? Or both the 3 and the 4? That'd be great. Okay, so that runs a little bit slow. Obviously, there is the string builder class, which someone mentioned in song form. String builder from system text, and that is a new string builder. And our string builder can do some magic for us. So instead of creating big text like this, I guess I'll create it there because it's not really going to make an impact. We're going to say append. So we're going to say string builder append I, and this is going to sort of add it into the collection. And now, because I really do want to create the same thing where big text gets this value, I'm going to say sb.toString. Now, I'm not printing it out, but we can still all agree that this has the same result, that at the end, big text has the same value, because before I was concatenating a string, and now I'm appending on the end of it and toString it. So this should come up with the same value. So when I run this, does it take 10 seconds? No. Look at that. That is faster than the 10,000 on the regular string. So then what if I go up even bigger? And I, go to, say, 100 million. Maybe I'll run out of memory first if I start adding numbers in here. You use base 60 for time and angles. Yes, exactly, Grumpy Game Dev. That's why. So when you talk to people about bases and you talk to them about an hour, if I said, hey, this is going to take a quarter of an hour. Oh, okay. That's easy. Quarters of an hour is 15 minutes. No fractional minutes in a quarter of an hour. You say it'll take a sixth of an hour. That's 10 minutes. A fifth of an hour. Like you want a third of an hour, a second, like literally 1 through 6. Like you can either have the full hour, half an hour, a third of an hour, a fourth of an hour, a fifth of an hour, a sixth of an hour. It doesn't matter. You get them, and so it's like, congratulations. This is just ideal. So, yep, it's good stuff. Okay, so we did this up to 100 million now, and it only took 4 seconds. So 100 million on here is faster than 100,000 on strings. So clearly, if you're going to be concatenating strings, even in the small scale, because notice all we did was 10,000, right? And you might be thinking like, well, 10,000 is a lot. It's like, it is a lot, but 10,000 is in the range where someone might consider not using a string builder, because it doesn't seem like, oh, we're not doing millions. It's like, no, even at 10,000, it was still better to use a string builder than a string. So it's kind of ridiculous. Yeah, you wouldn't do a seventh of an hour. But yeah, exactly. It's scary because 7, 8, 9. Wah, wah, wah. Thanks, Grumpy Game Dev. Okay, so cool. That's good stuff. Let's make some collections. So let's make a collection. I want to make a new list. So we're going to do this before we check the performance. The list creation is going to happen at the beginning. So let's put this up here. So I want to make a list. So we're going to do a list of GUID. Just because we're being weird. We'll call this IDs equals a new list of GUID. So we have a list of GUIDs. We're going to make them. How are we going to make that list of GUIDs? Well, we're just going to say IDs dot add. And we're going to say GUID dot new GUID. Congratulations. You now have a giant list of GUID. Now, again, these collections, while they did not have the capacity at the beginning, because I'm not going to bother putting that in there because it's just weird and confusing and it's not going to make a difference in the performance anyway, at least for our testing purposes here. This will put 100,000 GUIDs inside of the collection because it's going to grow exponentially in order to fit this size. So there's our GUIDs. Okay. So set of GUIDs. Excellent. We're going to take these and we're going to go ahead and say inside of our stopwatch, here's where our code goes. Let's say IDs order by someone's getting worried here. Order by the first character. ToString no, let's not do the first. Let's order by only the last letter. So whatever the last value is in there, the last digit, we're just gonna put it in order, and it should go 0 to F, I think, because yeah, numbers would come before letters, so it should work fine. Okay, this will be a little weird. Let's see how long this takes. So we're gonna just use the link order by and take a look. Pretty quick. Maybe we need to go bigger. I think we need to go bigger. Let's see if we can get close to a second. You know what? You know what we didn't do? We need to do this because we didn't really do it. I forgot. Var ordered equals that. We have to resolve it. That is my mistake. I apologize. This is where the time is going to happen. That was my bad. I set up the wrong thing. There we go. That one took time. Okay, not a ton of time. Almost a second, but it did take time. Let's have a look at some other methods. So we have that one that we just tried. Now, how else could we have done this? We can sort because it is a list. Now, this should give us some kind of compare, and I don't have a good comparer to use. So I guess it doesn't matter how it's sorted. I guess you could order it by the value or do this. So I'll apples to apples comparison this. This does it in place, doesn't it? So I don't need the value. So I can do this to sort it, or the other one. So I'm going to run the other one first without changing the value, so it does apples to apples comparison. So we're just going to do this. We're just going to order it by that value, and this should effectively sort the list and store it in that collection. Now, this does give me a list assignment, I think, when it does this. So there is an added bit of extra here, but again, if you wrote this code, you'd still get this problem. So we've ordered it here, so it cuts out some of the steps, so it's a little bit faster. So it's about a half a second to do it that way. Now, here's the question. I don't know which one's going to be faster here. I suspect the list, but I don't know for certain. Ooh, slightly faster. And that is actually close enough that this one might deserve benchmarking to find out if the sort is faster than the order by. Now, I suspected that maybe they had the order by calling the sort underneath the hood, because if they did a pattern match and just said, hey, was your enumerable, because remember, order by is running on an enumerable. It's running on an IEnumerable interface, and so this extension method for that could be running on an array, or it could be running on something that really is not a collection, it just is a sequence, or it could be running on, the list type. It could be, a sequence that happens to be a linked list of some kind, or it could be, who knows what, right? Because anything can implement that interface, and it just gives you the sequence. So we don't know what it is, but when they're running that, they could check the type that you had to see if you'd given them a list or an array or something like that before they run the execution and say, what type did you give me? Because checking the type is not a costly operation to do at that point. So they could just say, because remember, the amount of time to check the type of that object is not related to the size of the collection. So if you have 1 million items in the collection, it doesn't matter that you check the type once, because that's the type of the sequence, not of the collection, because it's an IEnumerable, not a collection necessarily. And so they could say, if this is a list, just run the sort method, because they would be like, oh yeah, we know what you're calling. You're calling order, so we could just call sort. So that may end up doing the same thing underneath the hood, but I'd expect the times to be closer. That's why I'm wondering about the benchmark. So let me go ahead and run it a couple of times. Exactly. It is a constant time check to do that. Okay, that seemed about the same. Whoops. Did I have them both running? No. Okay, so that one always takes about a half a second, and this one seems to always take about a third of a second. Let me just run this a couple of times and just sanity check myself here. Yeah. Okay, good. So I didn't mess that up. Yeah. Big O notation has been cited. Yes, we have that in the chat. These are the kinds of things that are happening, right? Like a sort is going to be based on n, but checking a type is not. So, I don't know which sorting algorithm this one uses by default. Do they tell us? Sorts using the default comparer, but they don't tell us the sorting algorithm. Now, the interesting thing here, we could check the source code on this. I'm not going to do it right now, but there are some sorting algorithms work better based on the size of the collection. So since this is on list, they could check the size of the collection to determine how they want to do the sorting, to sort of pick an algorithm that makes more sense. I don't know whether they do that or not, but sorting 100 items versus sorting 1 million items is like, you don't usually use the same algorithms for that, but who knows? Not that 1 million even requires a great sorting algorithm either, but we get the point. Okay, so we've looked at that. Now, we did a little bit of weirdness already with strings. Do we want to do a little bit more with strings? I kind of do. What do we want to look at? That's a good question. How about dictionaries and lists? Dictionaries and lists sound good. Let's try this. So we'll have a list of IDs and a dictionary of those IDs. All right, so here's what we're going to do. List of IDs and dictionary. So this is a dictionary, and this will be a list. So yes, if you're wondering, for anybody that goes like, oh no, Hungarian naming, no, like something like that, right? Someone's going to freak out about that. There is actually a time for it, and that is when the type of the object actually mattered. So if you're dealing with code that is translating from one type to another, so you're moving something from a string value to an integer value, so you're parsing it or something like that, listing one as the string and one as the int is not the worst idea. If types matter in the code, that's when you write the type in the variable name. If the type didn't matter, then you shouldn't have it. So, for example, if you've got like a username or a full name, you don't need to say full name string, right? someone can probably intuit that full name was a string. Now, it could have been like a specialized name type or something like that, right? And yes, we're going to miss that detail when that's going on. But again, if you had code that translated from a string to one of those, or from one of those complex types into a string, again, you might use that naming notation. All right. Let's go ahead and dictionary. Dictionary hash table. We're going to hash that. We're just going to do a hash set. Okay. For anyone that doesn't know, because this gets into the weirder parts of programming, so it's perfectly normal to not know what really like hash sets and things like that are. Sort of the way that a dictionary works is it's like a hash table that keeps that has an associated value. So that's sort of how they work. Is they use a hash table to as sort of the lookup for another value. In our case, since I'm just storing the GUID and just storing in between both a list and in a hashed version, the point is that within a hashed version, you do a little calculation to determine where in the set that one's supposed to be. So it's like a mathematical way of jumping to specific points in a collection for a specific value. Essentially, the idea is if you wanted to find a value in a list, you kind of got to walk it and find the one. So many of us get into this habit. I know I'm guilty of this as well, where we have a collection and we say, well, linked can just grab an item right out of the middle, right? Why not? So we're going to have a look at how bad it is to store things and find them in a list versus finding it, say, in a dictionary. If you were able to insert it from the GUID to begin with, why wouldn't you insert it based on this ID and be able to look it up later? So if you're going to have a collection that you're going to need to look into at a later point, say you have cached a set of user data or something like that you're going to need to look up as you're doing some calculation or something like that, and you're not just going in order through the list, you might want to do this kind of approach because, again, it almost works like a database lookup to be able to jump into specific points instead of doing this. Would usually have your suffix of name string versus string. Yeah. The regardless of which side it's on, you're absolutely right though. And Grumpy Game Dev is correct. Hash sets have nothing to do with any kind of, maybe I'll say consumables of any kind. So we got our stopwatch. We're going to come down here. Let's try writing some code just about here. How about we for each over the list? We'll say, yeah, item in the list. No, let's go through the dictionary first. And now the reason I want to do this through the dictionary is the dictionary is not going to be in order. So every GUID should be unique. I'm just going to trust that we didn't have that magical collision of GUIDs doing a GUID.new GUID, which is technically possible, but I think we'd all win the lottery before that happened. Thanks, Grumpy Game Dev. Should list dictionary have the same guide added, or will it not? Same GUID. Oh, you're right. We do need to add the same GUID. Thank you for catching me. We do need it. We do need it. Yep. For what we're going to do, GUID equals GUID.new GUID. You are right. I was going to mess this up and it was going to fail. Although technically that would be an equally valid test, as funny as it is. So next time we're doing that. But we're going to do it differently. Because I don't need to mix them up in order to do this. So here's what we're going to do, because there's two different problems. So one of the things that people always ask when they're like, hey, yeah, I'm trying to fix the performance of this and blah, 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 blah. And they're like, yeah. And they're wondering, like, what's faster? Is it faster to look for the error or to catch the exception? And the funny thing being that if the exception is exceedingly rare and you're going to do like billions of operations and never have the error, then it's actually better to catch the exception. Which sounds strange, but if it's going to happen, sometimes maybe, then you're better off watching for it to avoid that, because the amount of time to check will add up over like lots and lots of operations, which is weird and doesn't make sense because we know it is much slower to catch an exception than it is to just check a value to avoid it. And it's like, well, unless it's exceedingly rare that you would have the exception. And I mean, like, you know, your program's going to be like running for hours without having the exception, you know. All right. Let's have a look at this. So we're gonna walk through the dictionary, and we are going to get the item in the list. Is this gonna be slow to do them all? Let's say grid found equals list dot find the x where x equals item. So this should always be a GUID also. So here's what we're going to do. We're going to try to find inside of this list the item that equals x and see if we can find it. And then we're going to check how long that took and print it out. For 1,000,000 items. I don't know how long this is going to take. The program, yeah, exactly, yes, exactly, Phantom. It's the, well, it's like, which one's faster? Well, it depends on how you're using it. So whenever people are like, which one's going to be faster? It's like, well, so some stuff is just straight up slower, and it's just going to be slower. So catching an exception, for example, in most people's cases is probably the slower operation. You're better off watching for what's going to cause the exception. It also leads to better experiences, because if you discover that there was going to be an exception and then handle it, then no exception ever gets thrown and things continue running, which that's part of the reason why exceptions are sort of named the way they are. They're supposed to be the exceptional case, not a regular part of the workflow. And that is, wow, this is taking a while. That is something that I think a lot of us programmers, a trap a lot of us have fallen into, is that we will work as if you know, an exception is a normal part of workflow, and it really shouldn't be. Let's try this with 100,000 items instead. Let's do one more limit on here. Let's change this, so instead of going dictionary, we're going to do dictionary and take... How about take 1,000? So we're going to take 1,000 items out of that dictionary and only try to find 1,000 items. There we go. So 1,000 is not too bad. So let's make it 100,000 and try that again. Because 1,000 was pretty quick. Let's try 100,000, see if that is any quicker. So the 100,000 items, I think for this it should be linear, but it'll give us a better better average. Taking the 100 items out of the dictionary, I would think this would be pretty quick. "30 seconds. Wow, that took a while. Okay, so it took us 30 seconds to essentially go and find 100,000 random items. I say random in that it's not really random, but it's like they're somewhere in there. We don't know exactly where they are inside of that collection. So the GUIDs are pseudo-randomly generated, essentially, and we put them into that list. And it took us about 30 seconds to find them all. Let's reverse this. Let's say we were trying to find items in the dictionary instead. So we're going to cut this, paste that, chop that, put it down here. Instead of find, we are just going to do this. So, oh, is it, it's not, did I call it a dictionary? I did call it a dictionary. Well, it's a hash dictionary. Does it not have a... I swear I could just do this. Try get value, that's what it is. But is it not? I thought there was just a... Maybe I'm going crazy here for a second. I swear that's what it is. I'm going to jump over here just so I get the slightly better IntelliSense. Yeah, there we go. I thought there was a get that wasn't a try get. Am I crazy on that? I thought there was. I mean, I guess I can try get value, and it should still be a whole bunch faster. So we're looking for item, and we're going to do an out item, and then we're going to say out GUID found. And it's going to do the same thing, right? So at the end of this code, we still have an item called found, like we've essentially assigned a variable into there. So it should be the same code. And let's try running this, and we'll see what we get. So we run that, and look at that. So we went from 30 seconds to a tenth of a second. No, a hundredth of a second. So this difference of like, we don't even need to take, right? We can get rid of this. In fact, maybe just to be fair, I will take literally all of them just in case the take itself slowed stuff down. We can take literally the million, and look at that. Look at that. The million versus 100,000 was about the same amount of time. Look, you can't, like, it's a rounding error, the difference between that, because the amount of time that it is taking to check and get that value out of the hash set is literally constant time. Whereas when we were doing the other one, it was having to step through that collection and check the values in each, in each slot of that list to try to see, are you my GUID? 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 And it's doing that the whole way. So it is just crazy how much faster it is to use a dictionary if you're going to look things up. And if you go, well, yeah, Brendan, but it took time to create that dictionary. Oh, did it? Did it, random me that's speaking somehow thing? Okay, cool. If you're going to tell me that, then let's look at that one and see whether it did or not. Silly me. Hang on. I need to defeat Strawman me. Wow, spam. Do I need to... I think I need to get some moderators. Block. Yeah. You're definitely gonna get some moderators. You got spam coming in. Horrible spammy people. Okay, so... yes, exactly. Everybody wanted spam. Alright. So, we have some hash sets here, and we're going to fill them up with stuff. Let's go ahead and make these collections big, because someone says in this, straw man that I created that it takes a long time to fill these. So we're going to put this down here. We're going to measure the amount of time it takes to fill the collections. So the first thing we're going to do is attempt to fill the list and see how long it takes. Maybe we should go even bigger. We'll do 1 billion items in the list. Oh, Bread, you're Greendolf! Oh, that's awesome. Yeah. I don't know how to make people mods on here. I will have to do that at some point. Where did Stu get to? There you are, buddy. Add moderator. There you go. Thanks, mods. I just bumped some people to moderators. So, if any of you don't want to be a moderator that I just bumped to be a moderator, feel free to tell me and I will remove you from the moderator list. Okay, so let's have a look at what we got. Let's run this, see if this takes any time at all to run. We have our stopwatch there. We're going to put 1 billion items into a list. That's going to be a massive list. It's going to be a little crazy. We'll see how long it takes. Luckily, the computer's got plenty of memory, so we shouldn't crash it. I remember back when I was a college student, long time ago, we grabbed we had one person with a laptop running Linux, one person with a laptop running Mac OS, and one with a laptop running Windows. So we had Windows, Mac, and Linux. And what we decided to do was we wrote programs intentionally designed to crash the computer in different ways. So whether it would be just straight up starting to delete files in the file system until it crashed, and then we were just going to wipe the drives and fix it, or whether it was just like running out of memory, running out of threads, like whatever it was you were doing. We're just like, all right, the goal was let it lock up the computer, and then see if you can save it was sort of the idea. So we let it run for a while on all the computers at the same time, and basically, like, essentially, once your computer is crashing and dying, you have to try to save your computer before it dies. I can assure you, yes, the silly things that people do. We're going to cut this a little bit shorter. That's getting long. Let's just drop it back to 1 million instead of 1 billion, and then this one's probably just going to be so slow that we're not even going to notice the problem. Or it's going to be so fast we're not even going to be able to see it. Yeah, exactly, Grumpy Game Dev. It's not a joke. We really did this. We were just having fun. The Windows machine was usually able to break out, and we were usually able to kind of save it from destroying itself. The Mac just died. We were unable to save it like any time. And the Linux machine was always able to recover itself pretty well. So it was just weird fun. Did I make an infinite loop that that I didn't notice? I'm gonna check. Did we make a Yeah, we sort of did. Then for I, so we make this, and then we say for that, add this, and then stop, and then right line the time. Yeah. Okay. Okay, there we go. That's better. So, does that mean I can do this again? What else do I do this? Can I go to 1 billion? Adding to the list, going to 1 billion. It's kind of slow, Brendan. All right. We're going to kill that. We're going to try it a little bit smaller. We'll go to 10 million. I want to get a time that we can actually see here, because a fraction of a second isn't enough. Okay, so that took more than a second. 1.2 seconds there. That's not bad. Okay. So we have our number for the list. So we know that adding an item into a list, and again, they're both starting off empty. There's not like, I'm not setting capacities on these, so they're having to grow. Let's see about the dictionary. So for the dictionary, remember, there is a little bit of time to put it in there. There we go. All right, so it took us an extra couple of seconds to fill up the dictionary. Remember that, because when we were doing the lookups and trying to find the values out of the dictionaries, it was definitely faster to do the lookup into the hash, whereas it's a little bit slower to fill it. So if your scenario is one where you are going to, load the collection once and then look into it multiple times, that is where it is going to be faster to use something like a hash set instead of a list. The amount of times that I see developers like literally just, and I'm guilty of this as well, that we just create lists like willy-nilly for like everything. We're just like, oh yeah, list, array, list. It's like, okay, how are we using this? And we don't even think about how are we going to use it. Now again, that falls into the idea of like premature optimization. But again, if you're going to do something like, oh yeah, I'm going to cache this and we're going to look it up later, then it's like, well, why not use, like, if you're going to look it up by ID later, why not put it in a dictionary then? If that's the goal, is to look it up by ID later. Now, obviously, I used a hash set, and I could have used a dictionary instead of a hash set. But if I do the dictionary, then I have to put another value. So probably what I would do if we were doing that is I would say dictionary GUID, just for testing purposes, because we don't really care what the value is. So so we can do this. Bread, I'm betting a sorted dictionary is not actually that a sorted list is not actually that bad. Let's give it a look. A sorted list of GUID. Won't let me get away with this. All right, we're switching to Visual Studio. Visual Studio, help me out here, buddy. Oh, it was just that I was missing that? I thought when I put that in there, it was going to put it up there. I guess we got a good this one also. Sorted list of GUID, so sorted list of GUID. So we're going to do the two tests here. Test number 1 is adding them to the list, and this will add with a key value, I believe, right? Yeah, so they'll be the same, so we'll do GUID, GUID, just like we were going to do for the dictionary. So the GUID and the key and the value are going to be the same. And then we'll do... do we run the stopwatch again? I think we'll run the stopwatch again. Because we're also supposed to do that lookup, like this. So we'll do this as the secondary value because we had been doing this lookup for them. Whoops. There we go. And then this will be sorted list. Now, I believe when we did it the first time, we did it for 100,000 items. So this is not quite an apples-to-apples comparison. So I guess we'll hold off on this for the moment, and we'll adjust that one back down. Let's go ahead and run it and see how long this takes. So it was 1 second for the list, 3.5 seconds for the hash set, and then the sorted list is slower. Whoa! The problem with a sorted list is this. So I think with a sorted list, you're normally expected to initialize it with a full set of data, and it will sort it once. And here's the problem. Because at all times it needs to keep it sorted, it is probably on each loop readjusting the collection. Yeah, exactly. We're putting in 1 million times, putting 10 million records in here. So it is constantly sorting and rearranging this collection. It is unbelievable what is going on with this list right now. It is like, this is exactly what you should not do with these lists. So, sort of the description I put up when I told people this video is it's less about prematurely optimizing and more about like not shooting yourself in the foot, because this is shooting yourself in the foot right here. This is falling into like a pit of just slowness right here. So in most developers' code, you need to not write slow code. It's not that you need to write like super optimized mega fast code. It's that you need to not write slow stuff. This is slow stuff. Expectation is that insert time is slower. Yeah, insert time here on the sorted list is just terrible. I'm gonna stop this. This is like minutes. Now here is what you're supposed to do with a sorted list, I believe, is make a list. And then I think add them into the list. How do you, is it add range on this? Hang on. We're gonna ask Visual Studio, it's got better IntelliSense for this. What is it? Let's not remove, so I don't think there is a good way to add it like that, but I thought then you'd do new sorted list, and pass in the collection, right? Isn't there a way to do it? Ooh, you pass in the you can pass in a dictionary. That'd be a cool way to do it. So realistically, if we wanted to make it, we would do this. Dictionary of GUID. and we'd say dictionary equals new dictionary. And then we could say this, because the dictionary wasn't that slow. So if you add them into the dictionary here, and then say sorted list equals, yeah, let's create it down here then. So we'll then create the new sorted list, and we will create it from the dictionary. So now, remember, that one took so long that we canceled it before it finished. It is terrible, but is it horrible? I don't know. Maybe. And there you go. So did I even get the time on it? Did it crash? What happened? Did I forget to console? Yeah, I had this commented out. But it did finish, and that's the key. Is like, remember, we cut this at like, it'd been going for 30 seconds, a minute, I don't know how long, and we just gave up. But when we run this one, you'll see it took 6.5 seconds. So clearly what that means is if you need to create a sorted list, do not build it an item at a time if it's large. Obviously, if we were doing like 1 million, 100,000, 10,000, it may not be that bad. But a sorted list of a reasonable size like this, we're actually dealing with a large quantity of data. Don't put it directly in a sorted list. You want to do a dictionary first, and then put it into a sorted list. I can assure you the sorted list would probably find those items very, very quickly. But that is another cool one to just see like how long that actually takes to build. What else could we take a look at? We could look at some of the differences between classes and records, for example. If we make two different classes, two different objects, I should say. Let's try it. What kind of object should we make? Public class. No, not program. We'll do person. And what are the most important things about a person? Well, the first thing is their internet handle. So we'll just say that's their alias. And what else do we need to know about a person? Shoe size. Yep, shoe size. Shoe size US. And, well, the problem is this person has to know their shoe size UK as well. So, yeah, if I can type. So, because those never match. So, like, we're going to have that. And now let's create a record of the same kind of thing. So, we will have a public record person R and person C. So we've got our record and our person. And then this one is going to have a string alias, an int, shoe size US, and a shoe size UK. And I am giving a disadvantage in some ways to the record at this point because I haven't. So if you're not familiar with record types and classes in C#, first off, I have a video here on my YouTube channel. Yes, here because I'm not on Twitch today, on my YouTube channel, that goes into the differences between record, struct, stuff like that. But this actually comes with a whole bunch of extra code the record does that's not in a class. But it also has like some restrictions in the way that it works. So the quick answer is record types are useful for data that you're not intending to change and not really do like a whole bunch of logic with. So it's not your, central model object that you're working with in your code. It's not that. It is more like a value type that you want to have. It's like a complex value type almost. So the base case, when they first started talking about it, I was like thrilled. In fact, back before they even called it record types, when they were just talking about having, a default constructor is what they were originally planning on making for us. We were going to have objects that were created by a default constructor. So you declare them kind of like this. And the advantage of these is they are very good for as like data transfer objects. So things that you might return from an API or something like that. So a lot of times the object that we return from an API is a flattened object, not the normal like structured multiple pieces that we have in like inside of our regular models. And then they're not always flat. I say flattened because they are usually flatter than we have in our model. but in our domain model, I should say. But these API models tend to be designed for how the code is going to get used, how the data is going to get used on a UI. And so that usually flattens out for a user because, well, we tend to spread things out to get reuse across different things. But when a user's looking at it, they want one full set of info. So either way, so we have this. These are about the same, but this one actually comes with extra. But again, it shouldn't be extra per item. So I'm gonna hope that that just comes out and in a way that doesn't affect things too much. So what do we want to do with these? Let's make 2 lists. Persons, parent, person C. So this will be the person class, classes, and records. Yeah, these collection types are great names right here. So we're gonna have the classes and the records. And how many do we want to put in? 1 million? We'll make 1 million people. All right. So classes equal, we'll say .add new person C. And records, we're going to do the same thing. And this is going to change to R and R. So there we go. So this one's complaining because it has a default constructor and this one does not. But what I'm going to do is hop over to here and you say, Brendan, you need a constructor for that? I do, thank you. All right, there's my constructor. So now we have a constructor for that one as well. So see, it's right here. And we come up here and these both need a constructor. So now we need to put in a name. So clearly the answer for name is alias, I should say, because it's your online handle. It's how cool you are. So this is Brendan and then a number. So Brendan and then I. And the reason I'm doing this is just so that we have individual separate strings for all of these, just to make sure that everybody gets one. Their shoe size. So we're going to go with like, US shoe sizes, which are totally normal. And then we're going to go with like UK shoe size, which I think might be 12 digits. I don't know how UK shoe sizes work, but they're different than mine, so they must have like 5 extra characters. So there we go. Excellent. So we have created our person, and class record. Now what do we want to do with these? Do we find maybe the averages? So this is actually our setup. It shouldn't be inside of the stopwatch. So that's our setup. So those essentially pre-populate our lists with these items. Now down here we want to do something like classes. First off, these shouldn't make a difference here, I don't think. But let's just sanity check. You know what? Maybe we do this. Instead of this weird number we did here, how about if we say 11 plus I? There you go. All right, so now we're going to average out the UK shoe size. Because that's the one we made weird. Somehow, despite the US one never changing, the UK one does. So I don't know. UK shoe sizes, I think, are a little different, but I think they're just like, slightly bigger or smaller. It's like difference between like Fahrenheit and Celsius. Not this silly shenanigans we're doing here. That's not bad. Now I'm going to assume that we get no difference really between these. Between the records and the classes, because it should be mostly based on the type, and there shouldn't be any extra weirdness here. Now, there could be something extra with the creation of the objects, and this actually might be something to look at with benchmark.net, where we actually want to see, like, well, what happens when you create these with this, and what happens when you create them with that. So, yeah, that's taking a while. Let's go ahead and give it a try. .NET Add package. It is. Can Brendan remember how it is cased? Nope. NuGet benchmark.net. Oh, right. They called it DOT. Good for them. That's how they should have done it. Whoa! Someone clicked a button. What button did someone click? I don't even know which button that is. Subscribe to the channel. Oh, that's funny. One of the mods wasn't even subscribed to the channel. Excellent. Thank you for clicking the button. Now it seems way less silly. Alright, so that ought to add that in. Do we still build? .NET build. Alright. And then we need to grab the it is benchmark on the class. So here we go. Let's try like public class testy. Tester. So we're gonna have tester, and this guy is gonna say void try classes. That's a benchmark. Okay, and then in classes, we're gonna do this one here. And then we're gonna say try records. And this one is going to get rid of the classes stuff. And this one's going to get rid of the records stuff. There we go. And then I forget what the command is to tell it to run this. Where is it? Interwebs. What's the command I run to tell you to run this? Someone's probably like, Brendan, it's this in chat, and I'm not even paying attention. Let's see. Yep, done. Alright, come in here, blah, blah, blah. Ah, there we go. Benchmark runner. That's what it is. Like, I know there's some stupid thing that's just like, do this and it's done. Alright, so we're just going to return. But then before we return, we're just going to do this. And the thing we're going to run is tester benchmark runner. We need using for that. There we go. That's the thing I couldn't remember. Alright. Let's... Oh, well, I guess we could build. But I meant to do this. I forget what that is. Dang it. What's the command for that? All right, .NET CLI. What's your configuration? There we go. Do. You know, maybe I should have done a smaller task now that I think about it. The reason I say this is some of these parts could take a little while because I think I left it in with the millions in there. But then again, we're trying to make large collections just to see what actually happens. Because we are wondering, creation of classes versus records. Is there a difference? We're just making them. We're sort of told that when there is a special type for something, say, like we're saying, records are better for this, and it's like, well, okay, better could be more convenience because we don't have to write as much code, which is absolutely convenience. Is there a cost to it? Is it going to be slower or faster for one or the other? And I do not actually know what the result of this is going to be. With most of the other stuff we ran, I had a pretty good idea of what the result was going to be. But I don't know if there's going to be a difference here. In theory, we're just making objects and throwing them away. Now, maybe there's more stuff with the record that has to get tossed when we do this. Because there's a little bit extra that's there, but then again, it should be class level, it should be like associated with the type, not individual instances of the objects. So I'm not sure what we're gonna get, and I don't know whether or not I have this doing too many items into the collections or not. And now that I think about it, I'm not even watching the performance on the computer. Oh, nice. We spiked up to like. We're only using 90% of the memory on the computer right now. That's all. That's all. Oh, but never mind. That's all Chrome. It's not really all Chrome, but I do think it's probably thrashing a little bit. I think we may have loaded a few too many items in for this benchmark. So it's probably about to be done, so I'm going to cancel it and try just cutting this a little short. So we're going to cut that down to 1 million. I should probably extract that somewhere so that we don't have the... So I don't have to adjust it in both places each time. But let's see if going with 1 million instead of 100 million, makes this finish fast enough that... Exactly, that's what I was gonna say. If it ends up paging because we had too much, that's why I killed it. Because I'm like, we can't actually know if I do that. So we shouldn't have a problem now, I don't think. I will watch memory just to make sure that we don't spike it this time. No, we're not spiking it this time. It's going fine, and it's finishing a lot faster too. So yeah, as long as we didn't grab all the memory on this, we're okay. Yeah, we're good. There we go. See? Much better. Yeah, and it's not spiking anything. Computer's at normal levels now. So apparently using 100 times as much memory on the collections. Because I don't know how quickly it was able to garbage collect all of that either. So, alright, there we go. All done. And I didn't even notice, watching memory consumption, there's not even a dip. So we didn't use enough memory to even register that anything happened there. So what do we got? All right. So, okay, that actually tells me that looking at that says there's no difference. That these are going to be exactly the same. So it looks like creation of types is not going to be a big deal. So there is apparently not really a cost to creating a class versus a record, and it should be about the same. I wouldn't consider, the 1% difference to be meaningful. Let's look at some other stuff. What do we want to check, chat? Oops, sorry. Well, you know what? We didn't check. Let's try. Let's try. Maybe. Well, I was thinking we could mess with link, but let's try for lists. For, and then we'll call this for each. We'll try the two of them, and I think now let me check real quickly on this. Can I do a constructor in this and it'll just run normally and everything? So yes. Okay. So let's make a private list of GUID again, because it doesn't matter what it is. We'll call this GUIDs equals new list of GUIDs. And then inside of the constructor, why, oh why, would you think that I wanted it to be called program? I think VS Code is looking at the class that I am in and assuming that that is the type that I'm working on, and it doesn't understand. Well, I said VS Code, but it could be like the C# extension in VS Code that is what assumed it would be called tester here instead of, or that assumed it would be called program instead of tester. So let's say GUIDs add. Let's do this. I guess we're doing a for loop for these regardless. We're gonna call this let's put in 1,000,000 because 100 million is probably too many for what we're doing. So we're gonna add in some GUIDs and GUID.newGUID. Boop. All right, so we have a whole bunch of GUIDs in here. And then if we want to do, let's hope it doesn't optimize these out. Well, I is less than GUIDs dot length count. Then we're gonna do that, and GUID saved equals, let's say current. That way it thinks we're doing something. I just want to hopefully trick the compiler so it doesn't like try to optimize these away or anything silly like that. Equals GUIDs I. So it should jump directly to that position because this is like a list is effectively an array. So these memory it should be known length and in order. So that should be a quick little operation to do there. And then this one, we were going to do the for each loop. For each GUID in GUIDs, we're going to set current equal to GUID. And I guess to make sure it really does this, we could have this return the GUID, right? Return the GUID. So we'll make this also a GUID, and then we will return current. Oh yeah, exactly. Yeah, Johan. You can actually put those separators in the number, whether it is base 10, you can put those in with hex, you can put them in with binary. So a lot of people find it very useful in binary because we're used to reading binary in like 4 and 8 digit sections to make it a little bit easier to read. And having that in with large numbers like this also makes it a lot easier to read. GUIDs, current, GUID. GUID doesn't exist at this point, but current does. Helps if I don't make the basic compiler error there. Yep, those are super useful. There's a lot of stuff done with number literals. I think around like C# 6 and 7 is around the time that those number literals started coming in. Super useful to have those in there if you're ever having to write large numbers. For example, I work with some companies that if they need a constant that is something along the lines of like number of hours and such time, and like they're, large digits and things like that. Writing them, with spaces like that, even at the thousands, is just super useful, because anytime you need to have, a number where you wouldn't even, like, being able to glance and be able to tell that something is 1,000 versus 10,000 or 100, it's like, well, you could look at it, you can tell, right? A lot of people are like, yeah, you can. It's like, but it is so nice to, like, at the thousandth place, just have that little separator there so you can see, especially when you get into like millions and billions and things like that. Being able to at a glance tell the difference between a billion and 100 million is just super useful. Okay, let's have a look at what we ended up getting. Oh, well, that's interesting. Look at that. I was not expecting that would be that much slower. I thought it might have actually been faster, but it's not. And I think the reason why is that we never assigned an object. So the for each loop assigns essentially it assigns a variable to point at this GUID. It's not really an object, but it's assigning a variable to point at the GUID. Ooh, GUID, it might be copying. Let's find out. So we're saying this. Could we make... So I now am wondering. So confirmed, the for each is slower than the for loop. So all the people that told us, like, it's faster to do this. Okay, you're right, you win. It was apparently faster to do that for this scenario, this exact one we're doing here. But I'm now wondering, can we abuse a for loop? Hang on. So you'll notice I might have titled this video that we were looking at performance, but at the end of the day, we are having fun with C# code here, and we're going to have fun with it whether you like it or not. No, just kidding. Like, who doesn't want to just mess around and see what weird stuff we can do? Come on. Like, this seems great. All right, so we're going to do... can we mess with this? I need to do an initialization, and then I need a way of breaking out of it. So here's what I'm thinking. I'm trying to think, like, can we destroy a for loop into a for each loop in some way? Like, can we break this thing and be like, here's a GUID empty on your thing, but then we still are gonna have to be able to break out, and I don't know how we break out then, without also keeping track of the number. Well, I guess I could put it out here, and still increment it in there. Int I equals 0, and it still does this, but it doesn't then assign when I do that. For fun, you could sum a big list of ints with for each, and link. Oh yeah, Bread, I'm doing that one next. We're gonna sum some numbers with for each and link some. Have a good doctor's appointment. Hopefully it goes well. Hopefully it's just a routine well visit. .NET 7 has some auto vectorization magic. Oh, well, that could actually be really fun then. Let me see if I can do the horrible right here, and find a way to, because I still need to increment this I. I mean, the short answer is you could do it at the end of the loop, right? You could always do this. Well, actually, now that I think about it, you could do it like here. So, well, if you did this here and then you assigned, and it doesn't matter which one it is, and you assign the GUID and then it gets out of there. So then the last step of this is, so this has to get assigned to GUID, I, and then this is the step that happens at the end of each loop as well. The problem is I'm still keeping track of an I, and I'm not sure if there's a way to get a second I declared in the left part of a for or not. Now, is this faster? That's the question. And by faster, I mean, have I slowed this one down enough that it is no longer still the faster way to do things? Because I'm now creating this variable. I guess I'm reassigning it each time, which I assume is what happens in a for each loop. I assume it uses one I assume it has one variable that it is changing the pointer in that variable and not creating new variables each time. I assume that's what the for each loop is doing. That may be an incorrect assumption on my part. Whoa, we blew up on something. That is awesome. All right, so we're gonna do the suggestion of we're gonna do the suggestion from Greendolf there. I think. So instead of GUID new GUID, we're gonna do we're gonna create random at the top. So we're gonna say private random random equals new random. And we're going to say, instead of GUIDs, it's going to be numbers. And we're not going to need that many numbers. So let's have a look at numbers. Numbers. And it's going to be random next. And it is going to be between 100 and 1,000. Just to get us some numbers to work with. We're going to find out what they are. We're not going to do that many of them. We're going to only do 1,000 numbers. So we're going to do 1,000 numbers. That way we don't get ridiculously large totals. 1,000's not... Well, you know what? Here, let's do it this way. We'll do the numbers between 10 and 100. That way we can have 1,000,000 numbers. And not have to worry about how big it gets. The total number, I should say. So those are going to be our initial numbers that we are working with. And then we're going to have a benchmark for 4. So we're going to have a sum equals that. It's going to return back an int because we're getting the total. So the sum is this, and we're going to do a basic for loop for numbers count. We're going to sum them all up. So sum plus equals I. Numbers I. And we're going to return back some chatter. What's going on? Greendall. Let's see. Generate values from math sign, and then sum should be close to 0. Yeah, we could do that. I think I set it to an amount that won't overflow though. This shouldn't overflow because I'm only going. I can't go above 100 million, so that can't overflow an int. So you're right. I could do more numbers if I did it that way. Yeah, it's a good point. I mean, the problem is if I do from -100 to 100. Actually, maybe I should do -80 to 100, so it still goes up. And then we'll do 10 million numbers. Actually, with that, we could probably get away with this and we won't overflow. So, there we go. We're going to sum these together, give us this int. You know, we could also do, just to avoid the overflow, we could long it. Because that'd be an int64, not a, like, it's not storing it in a weird way. So we'll just do that. So let's have a long here, and then this should be same concept, except we're going to for each it. So I'm just going to bring this down here, put that there, and then instead of this, we're going to say for each int number in numbers. We're going to say sum plus equals number. Long will get less benefit out of vectorization. That is a fair point. But, well, you know what? We'll run it both ways. We'll run it both ways. We'll see how it differs then too, because that would actually show us whether or not that would make the difference. So we did this, and then this last one is, we'll call it link sum just to be clear what that is. So for this one, we can just say return numbers dot sum, and the Yeah, so anybody that's ever writing that for loop, just remember this exists. We'll see how bad the performance is on any of them, because this may be the fastest. I don't know. We'll find out. Now this one, I believe sum is going to return an int. Yeah, so sum is returning an int here, and then I'm casting it as a long. So maybe since I can't get rid of that for this one, I'll just do it as a long as ints for now, and we won't do that comparison. Though I do kind of want to do that comparison for the other one. Since we're set up to do this, I'm going to run it this way, and we'll see what it does. I expect this to be quick, because adding numbers is just kind of what computers do, and we're not messing around with memory. So you may have noticed things that are slow are creating and destroying memory and printing text to the screen. So as long as you're not doing those, it's pretty quick. Never, ever, ever do string concatenation in loops. Or for that matter, console output inside of loops can also be dangerous if you don't know how large your n is. Huh. This is actually taking longer than I was expecting. I mean, yes, it's running a test on each of the three, just to see how they actually do, but... Oh, we had an outlier there on that one I saw there. Whoa! Whoa, that looks so much slower. Oh, no, okay, wait. Whoa, what just happened? What just happened? That time just... 10 million is a lot of sums, but it still shouldn't be that bad. Whoa! Okay, so I don't know if you were watching, but like the before numbers, when it was running the numbers on... that is crazy. So here's the one where it's doing the sum, right? And when it was doing the warm-up and everything, right? We're at like 200 and things like that. I'm like, wow, that's really slow. And then before actual run, it's still doing this, and it's like 200. And then it just plummets down way under. And I remember the other ones were at about 100 milliseconds was what it was listing there. And I was like, suddenly it just plummets. So if you look, the average on the sum is 60 milliseconds, whereas it's 90 for these. So that is actually a significant drop. So it looks like for summing, because the assignment of that integer is so minimal in terms of the impact that it actually has, that the for each loop does not really cost us anything when you're just doing a simple operation like this. But for the sum, wow, you weren't kidding, they optimized that. I now kind of want to see... So you mentioned that this was potentially something they changed in Net 7. Well, I should have Net 6 on this computer. Maybe I even have Net... Ooh, let me see if I've got Net 5 SDK still. I may. Let's see if it lets me get away with this. That's awesome. So I was doing a video a while back about aggregates. Yes, exactly. All right, I may not have Net 7. Let me try, or may not have Net 5 anymore. Let me try Net 6. I should still have this. I deleted SDKs recently, so I may have gotten rid of .NET 5. I don't do anything with .NET 5. I think I upgraded everything we've got to .NET 6, and if I left anything out, as soon as we mess with it again, it will be on .NET 6. So .NET 5 has already gone away. Like it's already dead. You think that is... yes. Now that I think about it, I should have reduced the number of sums that we do just to make it run this test a little bit faster. But again, the initial two should run at about the same speed as we saw the first time. But again, just to control for what might be running on my computer, we got to run them all together. You still support Core? You mean Core 3.1? Core 3.5 is not a thing. Or do you mean Framework 3.5? Which I hope you don't, but I don't know how bad my my lag is on here. I'm very used to if anyone in here is new, I am normally a Twitch streamer. I had been streaming on Twitch for about five years now, I think. 315. Okay, that makes more sense than 35. This is not D&D 35. So whoa, oh, what the? Oh man. That is terrible. Holy cow. Chat delay is pretty quick. Okay, good. So I had been Twitch streaming for a long time. I'm not even looking at our number of viewers. I'm assuming it's low because we don't have a lot of people chatting. Usually we've got like, 30, 40 some people in our chat. Back when I used to stream regularly, because I used to, years ago, I used to stream all the time. And when we streamed regularly, we'd usually have like 50 people and lots of chat, and I usually couldn't keep up, and chat could get me distracted pretty easily. But I have no idea how many people we've got here. But either way, welcome. My name is Brendan, and I like code. But this is nuts. So you're telling me between .NET 6 and .NET 7, they took something that took 883 milliseconds and made it take like 60? That is wild. That is wild. The for each sped up 2, and I'm wondering, is that legitimately an improvement? Because it may be. They might have done something that sped up the for each loop. So if they did, that's really cool. Can I hang on? .NET framework using new project syntax. If I'm just trying to remember, like, what's the target framework? They improved enumerators for underlying collection types like lists. Okay. Yeah, so I'm using an SDK style project. Thank you. Okay, here's what it is. Net 4.8 is what I want. Net 4.8. Let's try this. Let's see if we can get any worse. Let's see. I don't know if this is going to build. Invalid. Nullable enabled. Yeah. Whoops. That is not a thing back in 4.8, is it? No. Global using directives. Yeah, we don't have those. Okay, so we got to turn this one off. And does that mean that I'm missing like a system somewhere? I bet I am. Yeah, for system, yeah, because system collection, I probably don't have these at the top because I don't need them with implicit usings. Because some of these just silly ones you don't even need because they're just like, yeah, of course you've got, yeah, you need system, yeah, we just put it up there because it was no, and here's link. Okay, it's all this stuff I have to add just to be able to use .NET Framework. The little things that you forget you're even taking advantage of because they're just there. Okay, hang on. Which did I run this? Which one am I missing? There is a record. I don't have records in this version of C#. All right, that's fine. That's fine. We're not using these right now anyway, are we? I don't think we're using them anyway, so it doesn't matter. Let's compare. How bad is Net Framework for these things? Now remember, in Net 7, it was 90 milliseconds, 90 milliseconds, and 60 milliseconds was the comparison. So this is before the actual run, so it's basically like... So if you don't know, the way that the benchmark.net works is it sort of like... Because it wants to get realistic numbers, it's running it beforehand. So it's going to run it sometimes so it can get, the warmed up version of it. So that you don't get the, like, oh, there was some kink, right? Because they're trying to get you real, like... They don't want to get numbers that are, just the outliers, right? Because any given time you run something, you can grab the... Oh, man! Oh! Look at that! Look at that! almost a second on each of those. 770 milliseconds, 800 milliseconds. Yeah, exactly. Yes. Look at this. That is wild. Did you see that, Brad? Look at this. Oh man. So when you try to, so like I have tried to explain to people that like if you just switch to like, because I knew you were supposed to get this, and it's nice to see the numbers. I've told plenty of people like basically like Microsoft's been saying that if you just switch to .NET Core instead of .NET, it's literally just going to run faster. And for many of us, it's felt faster. And a lot of our like load testing, performance testing tends to show that generally also. But looking at the simple thing of like just this for loop here, that is crazy how much faster that for loop is over the for each. And the link sum, if I mean, for a small collection, it's going to be fine, right? It's not going to make a difference. But if you are summing up, you know, a large section of stuff, say you've got like, you know, a whole collection of data, and you're like, yeah, just sum, and you're like, yeah, that's an easy way to do it. It's like it is easy code, but wow, that is just unbelievably slower to sum up those numbers, considering that you're really doing nothing. Um, that's just a nice little cost there. So what this says to me, if you want to get like the how do I get some optimization without, you know, thinking about it, without working on it, because, you know, premature optimization is a problem that, you know, happens in a lot of projects. People focus so much on that they're not, you know, solving things nicely. This says to me, switch to .NET 7. That is what this is saying right here. So if you just jump to .NET 7, instead of taking 700 milliseconds, this one should run fine this way. The fact that our using statements at the top of the file don't matter should not make a difference. But we should now be back to like 60 milliseconds instead of like 800 milliseconds. So when they cut it down to take a tenth of the time, that is pretty darn good. I cannot fault them on that. Well done. Well done. And just so you know, for anybody that is wondering, there are a lot of companies that are still running .NET Framework. As much as you'll hear people like me and a lot of the other voices in the community talking about .NET and .NET Core and that sort of thing, there are so many clients that I work with all the time that have legacy code that is running very old versions of stuff that they are migrating off, that they're maintaining, that there are still people fixing bugs and writing new features for all the time. So a lot of this kind of stuff it's out there, and if you can migrate it, you should. If you can do it, you know, for in ways that make sense for the company. So good stuff. There we go. We back to normal? Back to normal. All right. So we talked about summing being faster. I'm assuming all the stuff like finding minimum numbers and other things like that is also much faster than it was before. We can check that really quickly by just commenting out this and having a look at one of these things like, you know, an average, for example, across this should also be fast. This wants to return back a double. So we'll see if it lets me get away with that. Just chopping off just chop our double to an int. Just so we can see how long it takes. This won't get us the comparison because I'm not writing the logic for the other ones right now. I mean, I can write that, but I'm assuming that any of these aggregates that they've got, for those of you that don't know, the reason we're saying aggregate for these is that there is also a method called aggregate. You may have also seen a similar method in JavaScript called reduce, and those methods exist in a bunch of different languages. Essentially, it's like they're doing an aggregation of all the objects. So it's essentially we're trying to do some calculation along a whole set, making changes as we go. So you can do that kind of operation with like sums and other things like that. Those are the common scenarios. But there are other things that you can do with aggregates as well to make some of these changes. Wow, yes, see? Here's another one, lightning fast, for 40 milliseconds. But if we shift this, wow, let me open all these. That's gonna go great. To back to net 4.8. So 40 milliseconds is how long it takes in net 7. What about in net framework 4.8? I have a feeling it's going to be much slower. I don't. I assume they do not use the aggregate underneath the hood for some, but maybe they do. I don't know that. I haven't looked at what the current source code is for the sum. You can set up benchmark.net to automatically compare different target frameworks. Ooh, I should pass those in then. But either way, it went from 40 milliseconds to almost 800 milliseconds again. So it looks like the same concept is applying across the board, that that the whole set is just much faster. So I guess the answer is, if you're using the link extension methods and you're not on .NET 7 yet, you should be. Because even so, the .NET Framework to .NET Core was a massive increase, but .NET 6 to .NET 7 seems to be another huge step, like basically cutting the time more than in half on these. So, it's not going to be like, oh yeah, suddenly my application went from slow to fast. It's like, no, it's just some of these little things you can just make little bits a little bit snappier. Can really help with stuff. Well, on the same token that you mentioned with the speed up not necessarily being on all computers, there's also the fact that my computer does not host production applications either. So these days, most of the stuff that I would run on a lot of times is going to be some kind of cloud hardware somewhere, some other hosting environment. So the real question is it going to pick up any of those benefits when it's running out in those? Because that's where it's really going to matter. Well, let's find out. So you're thinking that I should just go here and say... that. True. So there you go. As no one is surprised, hardware acceleration for vectors in mind. So, which I think we suspect, because that is what you were commenting. They changed that should have increased the performance there, specifically with those aggregates. So yay. Well, that is some cool stuff. So, yeah, fun. Well, I'm hoping that was fun. I had fun. I want to talk with people a little bit, so don't go yet. I am going to wrap up the stream because I was planning on doing a 2-hour stream today, not a long one today, just a short one. Again, I wanted to try out YouTube, and please tell me what you think of this. So if you are someone that watches my streams on Twitch and my streams on YouTube, please let me know what you think about the YouTube one versus the Twitch one, because I do want some feedback on that. I would like to know, did people think this one was interesting? Would you rather I go back to streaming on Twitch? Would you like me to stay here on YouTube? So if you've got preferences, I know I don't have a whole bunch of emotes here. In order for them to do that, I have to have some level of viewership or something like that. I have no idea what the rules are. Every streaming platform has different rules for what they can do before that. Back on Twitch, it was like some amount of viewership before you could have emotes. You prefer the YouTube streams, but that could be yeah. So that's why I'm wondering what people think. So if you are someone who's here, especially if you're a new person, also, if you are not someone that watches my streams usually, let me hang on. So as I said, don't go just yet. I do want to see. Do these work? Nope. Streamlabs may not be here. Um, well, then I don't have fancy links to go to all the various stuff. But what I could do is send people some links to the stuff. I think it's like chatter.dev Discord. And nope, I typoed it. Ha ha ha. Discord and chatter.dev slash so if you are someone that is new here, feel free to join our Discord. That is one of the ways that I communicate with people about streams we're going to be doing. We have a nice community over there of friendly people that talk about different stuff. I've actually started on an open source project. If you are, especially if you're one of our regulars, if you'd be interested in working on that, let me know. I haven't really been talking about it in the Discord lately, but I have been talking about it on social media in some spots. I don't know who here follows me in which media, but if you are interested, feel free to check that out. I'm assuming our viewership is lower on here than it usually is on Twitch because there weren't as many people chatting as we normally get. So that could be a reason for me to head back, just the fact that I've got community that exists over there. But if people really like the YouTube experience, I will, consider staying here as well. Again, I just need your feedback on that. We are obviously not going to be doing any raids or things like that. I'm not going to be streaming tomorrow or Friday, obviously, because of I live in the U.S., and so we've got our Thanksgiving holiday this week. But I am hoping to stream on Twitch and YouTube potentially next week. We'll see how that goes. I think maybe we'll do a Twitch stream and a YouTube stream and see how they both go. I would like to stream on both, but Twitch doesn't let me do that. I think if I did that, they would take away my emotes because, according to the contract, because I think you'd have to be not an affiliate with Twitch in order to stream in both at the same time. They require that you be exclusive. So it's a little annoying because it's like, look, I just want to have some emotes like in my chat because they're fun. Why do you have to lock this? But meh. Anyway, I hope everybody has an awesome day. It was really fun coding with all of you, and I look forward to seeing you next time. So have a great day. Happy coding. And if you're not subscribed, be sure to subscribe, because keep in mind, I do actually post videos here. Apart from whether or not I'm live streaming, there are videos that regularly appear on this YouTube channel about educational stuff about programming. So take care, everyone, and happy coding.